Okay, before we get started with the talk, just a few announcements to our attendee participants today. For those of you who have been around been with us since the morning or since yesterday, even, you will know how this works, but there might be some new people here as well, so let me explain some things. 発表前にちょっと参加者へのアナウンスがありますが、if you have purchased a ticket and you're watching us from YouTube Live, we recommend that you switch over to Zoom so you can ask questions and chat and use the chat feature. You should have the links to that in your Zoom ticket. For everybody who is here with us on Zoom, at the end of the talk, we will have a time for Q&A. And if you have a question, please raise your hand by clicking the participants button at the bottom of your screen and then the raise hand button in the panel that will pop out. トークの後に、Q&A 時間がありますので、その時は、Zoom 上で手を挙げてください。それは、Zoom の下のところにパーティシパントボタンがあって、そっちをクリックして、パーティシパントパネルが表示されます。そっちで、レイズハンドというボタンがあります。Could somebody in Zoom please raise your hand just for testing purposes? Zoom で参加した方、誰か手を挙げてください。確認のために、はい、高橋さん、ありがとうございます。こんな感じで、やってます。Okay. Thank you. And you can, of course, ask questions in chat as well if you don't have a camera or don't have a microphone. And I will then ask the question instead. If you are watching us from YouTube Live, you can, of course, tweet about this talk, tweet about this conference. Please use the hashtag PyConJP. Or for this talk in particular, use hashtag PyCon_2. Thank you very much. We're looking forward to your comments and impressions. Now, Chen-Ling-san, you should have gotten a little statement to read before your talk.
Yes.
Yes. So if we could just for mic check, to check that the levels of the microphone and everything, the sound is okay. If you could read this now, please.
So because I couldn't find that document, so can I just read the slides like spatial boost, all the spatial boost you can get? It's how the company use Python for this. Is that okay?
There's a reason why there's a reason why we make you read this, and it's mic check is one big reason, but there's also
okay. So can you send me the documents link?
Absolutely. Give me 1 second.
I mean, can you give me the documents link so I can read that?
Yes. Yes. I have to find the link myself first. Okay, I think that's the one. I will share it with you on Zoom or Slack.
Okay.
Where are you? Okay, okay, so I'll share it with you on Zoom. I sent you a private message on Zoom.
Okay. Okay, I got it. Should I use my screen or I just read it?
You just have to read it.
Okay. So my name is Chen-Ling Yang. The title of my presentation is Your Escape Plan from Numpy and Cython. My presentation will be in English. The presentation material are in English, and I will publish the presentation materials. I agree to having my picture taken during my presentation. I will compile with the PyCon Japan's Code of Conduct.
Okay. Yeah, thank you very much.
No problem.
スタッフの方、音声大丈夫そうですか？熊谷さんとか。
OK です。
Hi, Almas. Okay, so it looks like everything is fine, so we can get started. Hi, Almas. Okay, let's get started, everyone. Welcome everybody to Chen Linyan's presentation about your escape plan from Numpy and Cython. Chen Lin, take it away.
Okay, thank you. Hello, thank you for having me at PyCon Japan 2020. It's truly my honor to be here. And today's talk will be your escape plan from Numpy and Cython. Here's a little bit about myself. My name is Chen Linyan, and you can find me on my GitHub account, CLYANG. I'm a Taiwanese and live in Taipei now, and currently working for a cybersecurity company called Cycraft Japan. I'm also a member of machine learning team. So basically all my daily life is dealing with thousands of hundreds logs from the endpoints everywhere around the world. So that's also the main reason why I want to share this, because I deal with all this data with Python and NumPy. Okay, so before we start, here are one very quick question for you. Assuming that you have a very large NumPy array, and you want each element to multiply itself 8 times. Which of the following code do you think runs faster? Is it A, the power function of NumPy, or B, x times 8, or C, x times x and then repeat 4 times? I will give you a few seconds to think about it. Okay, time's up. So the answer is C, the most naive one, x times x, and then repeat 4 times. And in order to prove it, I also write a very small benchmark code to see the actual execution time of all those 3 options. So as you can see over here, the power function of NumPy and x times a, they both took about 2 seconds to finish. But for the last solution, the most naive one, you use x times x, and then it only took about 0.4 seconds. So it's about 5 times faster than the previous 2. Yeah, that's amazing, right? So this lesson teaches us that sometimes the most naive solution might be even faster than you think. And also, but there's a catch. The last solution, there will be a very, very small difference between this one and the previous 2. The difference is about 10 to the power of -20. So as you can see, that's a very small difference. But so unless you are doing the scientific computation, otherwise I believe the last one can help you a lot, and it gives you about 5 times faster in performance. Okay, so why not Cython? Right? In this slide, at least if you are ever encounter a performance issue with NumPy code, you might ask your friends, colleagues, or teachers how to improve your NumPy code. Most likely, the answer you will get is that why not try on Cython? So this page, I just list some pros and cons regarding to Cython. Let's have a look on advantage first. If you utilize Cython, of course, you can use all those third-party C libraries. And in the most of time, C code runs much faster than Python's code. And also, it allows you to release the global interpreter logs. So your multi-threaded program can run even faster. And still, you can have the runtime check for the very common issue like the boundary checks or the memory management issue provided by the upper layer Python. So you don't have to deal with it by yourself. And last point is that the Cython syntax is very similar to Python one. So you can very easily to pick it up and learn it. However, there are some disadvantages regarding to that. The first thing I can think is that you have to handle the memory by yourself. Because if you are using the malloc function in your Cython code, then all the memory management should be done by yourself. So you have to remember to release the memory after your code. Otherwise, you will suffer very serious memory leak issue. And also, if you want to get the ultimate performance, writing the C code and low-level intrinsics cannot be avoided, and sometimes it's very painful. So basically, all you have to do is write like something like this one, and it's really painful because the code on the screen is wrote by myself during my work. Okay, so let's move on to today's example. This example will be used as a benchmark code for the rest of this talk. So please have a look on it. If you are not new to machine learning, you must know what softmax function is. The formula is just like the one I show on the slides. And don't worry, I'm not going to explain it in a mathematical way. All you have to do, all you have to remember is that it's a number divided by a bunch of the sum of a bunch of numbers, and that will be enough. And as you can see, the formula, it is very easy to implement by programming language. However, if you really try to implement in Python, just like the formula I show on the screen, you will easily encounter the numerical issues. And in computer science, we call this issue underflow or overflow issue. On the next page, I will give you an underflow example to demonstrate it. To solve this kind of issue, there's a mathematical trick called logsum exponential, and this will help you to prevent the overflow or underflow issues. Okay, so here's the underflow example. Let's say this part of denominator, the sum of this part denominator will be 134217728, and the last part is it's reciprocal, so it's just 1 divided by 134217728. Okay, so then what will happen if you are trying to add these two parts together? Here's one very simple code to demonstrate it. So the variable a is just the number I just described, and then you try to print the sum of a and a's reciprocal for 3 times. As you can find the result over here, it's exactly the same as A. So this part will just be ignored. And you might think this might not a very big deal because the reciprocal of A is very, very small. But imagine if you are doing a scientific computation, for example, like doing the Markov chain, the input data will be a list of very small probability. So after a specific location, in my case, like this one, and every single small value after this location will be ignored, and that will affect your final result significantly. So to solve this problem, a very simple trick called logsum exponential can be used. And this formula shown on the slide is mathematically equal to the result of the softmax. And don't worry again, because I'm not going to prove it over here, but you can find the answer on the internet very easily. So by applying this formula and translate it into the Python code, you can see the final result over here. So as the result shows, there are very small difference between this result and the result on the previous page. The smaller value is preserved. Otherwise, so it proves that if you apply logsum exponential trick, it will help you to maintain your calculation results. Okay, so for some of you might already know, SciPy already has logsum exponential function. Why would you rebuild your own wheel? That's a very quick question. The answer to that is that the SciPy's function is normally built for the general purpose usage. So it will contain a lot of checks in order to to handle the input and output data in the correct form. However, in the real world scenario, you know what your data is, you know what your data look like. So you can actually rewrite the function not only to avoid a lot of additional checks, but also give you another chance to apply some performance improvement library to boost your code. So in my case, and also in the rest of this talk, I will assume all the input data will be one-dimensional array. Okay, so let's have a look. How do we implement the logsum exponential in NumPy? The code is just shown on the screen. So basically, based on my scenario, the input data will be just one-dimensional array. So logsum exponential can be implemented as follows. As you can see, it only took 3 lines of code to finish it. So it's very easy to do that. I will leave about a few seconds for you to view the code. So after we implement our own version of Numpy, we have to compare it with the original one. So here's the benchmark code. I just wrote our own implementation and then called the built-in SciPy function. The result is on the right of the slide. As you can see, our version is about 0.5 seconds faster than original one. And some of you might think 0.5 seconds is not a lot. But however, if you're thinking about code this function 1 million times a day, then it will help you to save about 500,000 seconds. That's not bad, right? Okay, so let's move on to today's first solution, CuPy. CuPy is an open source project developed by a Japanese company, and it provides NumPy compatible ND array on CUDA. So basically, it means that you can utilize all your GPU powers. And it also compatible with the existing CUDA kernels. So you don't have to waste all your hard work in previous CUDA kernel. You can just import it and use it. And also it provides many NumPy equivalent function for you to use it, so you can minimize your code refactoring effort. But please remember, there are still some difference between CuPy and NumPy. So please check on their website, and the page is very well written and describe the major difference between CuPy and NumPy. And the last thing I would like to remind you is that moving data between CPU and GPU is very expensive. So please use it wisely. Otherwise, instead of improve your code performance, it might drag your performance a lot. So how do we implement CuPy how do we implement logsum exponential in CuPy? It's very easy. All you have to do is import CuPy as CP. And then you can use you can try to use the NumPy function under CP. There's one thing I would like to remind you is that this is very critical one. So you have to compile your existing NumPy array by using CuPy.array. And then CuPy will help you to move your data from physical memory to graphic card memory. And then it will perform all the calculation. So after we run this code, the result is pretty amazing. The running time is cutting from 6.7 seconds down to 1.6 seconds. So it's about 5 times faster than the original SciPy version. Okay, so now moving on to the second solution, Numba. Numba is a very popular NumPy and Python code boosting solution, and it is also backed by many large companies and organizations. The approach Numba uses is just-in-time technology. So basically, it means it will translate a subset of your own Python or your NumPy code into low-level machine code and run faster. It also provides the ability to utilize the both CPU and GPU power. And one of the best things Numba has is that it also supports OpenMP. So it means that you can parallel your code very easily. The highlight of Numba is that it provides near zero code modification. So all you have to do is to put a very special decorator at JIT before the function you would like to speed up, and then Numba will do the magic for you. And currently, Numba only works best with the functions, not classes. So if you have a lot of classes want to improve its performance by Numba, I will suggest you not right now, because it's still in a very early development. And another advantage about Numba is that it has a very large user community. So it means that if you have any question, you can easily find the answer on the Stack Overflow. To use Numba, 2 modes you have to know: the no Python mode and also the object mode. So in the no Python mode, Numba will help you to get rid of the Python's global interpreter log. So it will allows you to get the most performance out of your code. However, not every NumPy code is supported in no Python mode. So you have to look up the documentation in Numba's page. Luckily, it's very well written, so it shouldn't be that hard to find the mapping. So if the no Python mode doesn't work, don't worry, you still can fall back to the object mode to give it a try. And to use the OpenMP with Numba, you have to use it under Node.js code. So here's a very simple example. All you have to do is use it in under the Node.js mode, and then you just change your original code from the range to p range. So just one character change, and then Numba will help you to parallel this calculation. So that's pretty amazing, right? So how exactly we implement the logsum exponential by Numba? It's much easier than you expect. All you have to do is put these two spatial decorator at JIT or at NJIT, and the rest of the code is exactly the same as the one we implement in NumPy, and the result is on the right. As you can see, the no Python mode with Numba is it's about 6 seconds to finish. However, in the JIT mode, it took 6.72 seconds. So it's about 0.02 seconds slower than the original SciPy's code. So you have to remember, if you want to try to apply all these solutions to improve your code, please remember to write the benchmark code, because sometimes it might give you even slower result rather than faster one. Okay, so let's move on to the last solution, Pythran. So in Pythran is a very actively developing project written by a French developer, and it has a very fast-growing community. So that's why I want to give you some introduction regarding to that. And unlike the Numba, which used the just-in-time technology, Pythran use ahead-of-time compiling technology. So basically, it means that you will try to translate part of your Python and NumPy code into C++ code, and then try to utilize modern compiler technology to compile it and optimize it into the very low-level machine code and run faster. And it also supports a subset of Python and NumPy's function and works on Python 2.7 and Python 3.6 to 3.8. And just like Numba, all you have to do is put a very special decorator before the function you want to boost. And also it supports OpenMP, so you can also do the p-range trick in Pythran. So how do we implement logsum exponential in Pythran? So normally it takes 2 steps. So the first step, all you have to do is write a Python code as usual. So here's the example code. So this part of code is exactly the same as the NumPy code again. And all you have to do is put a very spatial decorator, the hashtag Pythran export, and then your function's name and the data type of the input value, and that's it. So once you edit this file and save it, all you have to do is compile the file you just written. So here's the one very long command to compile this code. And you can also just do this one, the Pythran, and then your file name. It will also do the trick. The reason I use this long command because is that I want to give some compiling flags to improve its performance. So after you finish the first step and compiling it without any errors, all you have to do is import the just compile module and run it. So in the second code, I'm using I just import the compiled module and then call the function as usual. And here's the result. As you can see, it took about 5.4 seconds to run. So if you can recall, the original SciPy function took about 6.7, And the Numba's result is about 6 seconds with no Python mode. And in Pythran, it can give you extra performance boost. It can the running time of it is about 5.4 seconds. So that's about 20% faster than the original SciPy function. So basically, I just introduced 3 different types of solution that can improve your NumPy's performance. So right now, you might want to ask, which is better? So before we describe that, I would like to tell you some background regarding to the benchmark. All the benchmark in the previous page is run on a bare metal machine with a Intel CPU Xeon CPU with it 256 gigabyte, and it also comes with a GeForce GTX 1080 Ti graphic card. The Python version I use is 3.6.9, and all the library information and version information you can find in these slides. Okay, so in this slide, I just put all the results in the previous page into a bar chart so you can compare it by yourself. So the answer is quite clear. If you have a GPU, or even better, multiple GPUs, please give it CuPy a try, because it can easily boost your code performance greatly. In my case, it's 5 times. So it's just a no-brainer, and it's very easy to transit from the NumPy to CuPy. If you don't have any GPU, don't worry, you still have the options. So in this case, Pythran gives the most power of the boosting performance. So as you can see, it will give you like 20% faster than the original SciPy's implementation. That's not bad for just few lines of code change, and you can boost your code greatly. So I can call it a day. Okay, so at the end of this talk, I would like to give you my decision tree regarding to the CuPy, Numba, and Pythran. So the question was starting with, do you have CPU? If the answer is yes, and then the following question will be, do you need to run CUDA kernels? If the answer is still yes, and then I will suggest you to use CuPy. If the answer is no, then the other question would be, do you need to also run the CPU task with you? If the answer is yes, and then I will suggest you to use Numba. Otherwise, you can use CuPy. And what will happen if you don't have any GPU? Don't worry, you still have the options. And the question itself will be very easy. Do you like compiler? So basically, do you like to dealing with compiler? If the answer is no, then please use Numba, because it will give you the minimum compiling error or translation error for you. Otherwise, if you are a geek and like to dealing with the compiler flag, or all those compiler errors, and then Pythran will be your best choice. And in my own experience, I will use Pythran to get the most CPU power as many times as possible. So at the very end of this talk, I would like to give you 3 takeaways. First, if you have GPU, please do try CuPy, because it's just a no-brainer and can improve your NumPy's code greatly. And if you don't have GPU, don't worry. I would suggest you to try Numba first. The main reason I would suggest you to try Numba first is that Numba supports more NumPy function than Pythran. So in my own experience, my daily life work, I will try to improve my NumPy code with Numba and no Python in no Python mode. If it works perfectly, and then I will try to convert this code into Pythran to get more performance out of it. And the last takeaway would be, please remember, each solution, they support different numbers of NumPy's function. So please do remember to read the documentation on each solution's website. You can find all the supported NumPy function on their website. And also, you might want to ask, how do I know if the function is supported or not? Actually, it's very easy, because if the function is not supported, your program will just die. So you will know it immediately. And also, if A doesn't work, B might work. So in my own experience, sometimes CuPy doesn't work, but Numba works for specific function, or maybe Numba works and then Python doesn't work. So I would suggest you to use a mixture of solution. So in a real world scenario, I always use like CuPy with Numba or CuPy with Pythran to get most power of my GPU and CPU. So that's pretty much my talk today. Thank you. And because right now it's the pandemic for COVID-19, I hope you guys stay safe. Thank you. And do you have any questions?
Right. Yeah. Thank you very much, Jen. And great talk. Very interesting. All right. If you have a question for him, please raise your hand in Zoom in the participants tag if you want to ask the question yourself. And there's a question in chat. You can still raise your hand and I will call you out, but a question in chat. In Pythran, directives are given with the #, so it can be run by usual Python regarding them as comments. Is that correct?
Yes, that's correct. So you cannot run this code in Python because you will just treat it as a comment. So you have to use Pythran to compile it. So in my slide, I will give you a very long compiling command to compile it. So basically, you can always try it on Pythran and space, and then your file name to compile the file. And you will compile as a module, and then you can import it.
Yeah, and then there's it's not a question, but it's a comment that I like, and I agree with the decision tree that you made. That was very useful to see on one screen what's going on and what to use. Nobody's raising their hand, so I will use this chance to ask a question myself.
Okay.
You mentioned multiple times that all these different tools have different levels of support for different parts of NumPy, for example. And I was wondering, like, when something is not supported, it obviously, I assume it errors or it crashes or something. And I was wondering how the error reporting compares between the tools. Like,
regarding to
does one tool have a much better error handling or like reporting or something like that?
No, the program will just throw out some exception and your program will just die. And so you will immediately know this function is not supported.
Okay. Yeah, thank you.
And in my own experience, there's one very simple trick in my own experience. If your NumPy function is involving with the axis, axis, this argument, most of these, I think this three solution does not support it very well. So normally the major issue I will face is that the input data with very multiple dimensions. And then I try to convert the metric, and then I will have the issue with that.
Yes, I was also, sort of related to that. I was also wondering with, I think it was Pythran, where you have to explicitly give it a input type, right?
Yes.
I assume if you call that function with the wrong type, it will just crash.
Yeah, it will just crash. But there's one very nice thing regarding to Pythran, because you can give multiple decorator with the same function. So for example, if you cannot expect the input data is integer or float, you can just declare twice in front of the function. And then this function is able to take both integer and float.
Okay, that sounds great. And it looks like we are just about out of time, so we will finish here. Again, thank you very much.
No problem. Thank you very much.
Talk. If we can get some more 8s in chat, everybody. Okay, so what's going to happen next is that, well, actually right now at 3:20, the special booth tour starts again, like yesterday. So if you have a PyCon ticket, you can join that. and check out all our special booths. After that, if you want the next talk in English, that will be at 4 p.m. in room number 1. Tetsuo Koyama will talk about Jupyter notebooks and how to plot some data, which sounds very interesting. So make sure to check that out.